So,
I am from India.
today we are going to start with the haloalkenes and haloarenes. Okay. So first, let's understand these words. Always try to understand the word by breaking it. Haloalkenes. Halo word always used for the halogen group. Fluorine, chlorine, bromine, iodine. Right. And
Your
we
voice
just
is
denote
lagging.
this. Just a second, let me check the. Now check it. Is it okay, Aisha?
Sorry, your voice is lagging.
Just a second, let me check. Okay, now check, Aisha. Am I audible? Hello. Am I audible, Aisha Bachchan?
Not yet. It's still
I think there's,
lagging.
I don't know what's the problem. I think there's a problem with my Wi-Fi today.
I think it's my Wi-Fi. Do you mind giving me a second? I'll change my phone.
Yeah, hello. 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 Hello, Aisha.
Yes, hello.
Yeah. Now am I audible? Are you facing some
Yes.
network issue, bache?
Yes, I guess.
Okay. Okay, so we were discussing about the haloalkenes and haloarenes. Right, right. So
Yes.
halo word for the halogen group. Right. So halogen group क्या होता है? So basically halogen groups are the group 17 elements, fluorine, chlorine, bromine, and iodine, which is represented or denoted as X. Right. We just denote the halogen group as X. So haloalkenes. Alkenes means your single saturated hydrocarbons are known as alkenes, right? Which is having the general formula CnH2n plus 2, right? So haloalkanes means when you just replace one hydrogen. Suppose if I take methane, CH4, right? And if I replace this one hydrogen from one halogen group. Okay, if I remove this hydrogen group and if I attach the halogen group, any X group over there, so this is known as your haloalkane. Okay, so if one hydrogen is is replaced by any other halogen group, then it is known as haloalkenes, right? So this compound is known as haloalkenes. Haloalkenes. Right. And what is the formula of haloalkenes? And yeah, X could be your fluorine, either your chlorine, bromine, or iodine. Anything, any halogen group will be there, right? And what will be the formula? So if you are removing this one hydrogen from here, and if you are adding one halogen group over here, so what will be the formula? So the general formula of haloalkane is Cn, right? H2n plus 1 into your X, right?
Yes.
Into your
Yeah.
X. So suppose for this CH3, how we can write? We can write CH3X. So this is your formula. Got it, Aisha?
Yes.
Similarly, haloarenes. Arenes basically we used for the aromatic compounds. Aromatic compounds क्या होते हैं? Basically, aromatic compounds are the compounds just like your benzene, which has a conjugated pi system. Conjugated system means alternate single and double bond. You can see in benzene, this is the double bond over here, and this is a single bond. Alternate, you will see double bond, single bond, then double bond, then single bond, double bond, single bond. Right. So this type of a structure is known as aromatic, aryl system, right? Arene system. Okay, so this is your aromatic type of system. So in aromatic type of system, when suppose there is a hydrogen over here, right? So you can see each and every carbon, one, two, three bond and one hydrogen. Three bond and one hydrogen is there, right? So if one hydrogen is replaced, when you remove this hydrogen, and it is when you add the halogen group over there, so you will get haloarenes. You will get haloarenes. Right. So this structure is known as a Haloarenes. Is it clear now?
Yes.
Yeah. That's very simple. Now see, Aisha, classification of haloalkenes and haloarenes. So basically, on the basis of number of halogen atom, haloalkenes and haloarenes are classified in three types. Right? In three types. First type is when only one halogen atom is there. Only one halogen atom is present, then we called that type of haloalkane as monohaloalkane. For one, we just use the word mono. Mono means one. Di means two. Right? Similarly, tri means three. Right? So similarly, for one halogen atom, we use mono word. Right? And if it is haloalkane, if haloalkene is there and only one halogen group is attached to that alkane, we call it as a monohaloalkane, right? Similarly, if we have to then that only suppose there is a ring, means aromatic ring, and only one halogen group is attached over here. What we call it as? We call it as a monohaloarene, right? It's arene. You have to check whether it's an aromatic system or not. If the halogen group is attached to the aromatic ring, aromatic system, then it is known as monohaloarenes. Suppose if there are two halogen groups, right? So it will be called as a dihaloarenes, right? And halogen group should be called वो same भी हो सकता है, whether it could be same or it will be different. So suppose it's a chlorine group over here and this is a fluorine. And if I write fluorine over here, so both are fluorine. But again, we will call it as a dihaloarenes because two halogen groups are there, right? Two halogen groups are attached to the aromatic system. So this is known as your dihaloarenes. Similarly, if I attached one more, suppose chlorine, if I attach, so we call it as a trihaloarenes. Got it? So if you got it, just tell me. Just classify, you have to classify them on the basis of number of halogen atoms.
Oh, I have to answer you.
Yeah, you have to answer the first one.
Monohaloarene, and then
No. Just a
di
second. Just a second. Mono, halo.
arene
Are you sure it's arene? Are you sure? What I told you. Arene is the conjugated you have to check na, whether it's a aromatic resistance or not. Aromatic means double bond, then single bond, then double bond, then single bond. Alternate double and single bond. But this is the cyclic structure, right? This is a cyclic
Yes,
structure. So this is included in the alkane.
alkane.
Hydrocarbon. Yeah. So this is a monohaloalkane, not arene. Yeah.
Yes.
Can.
Then dihaloarene,
Very good. Dihaloarene. It's arene. Third one.
tri trihaloalkane,
Yeah. Good. No alkane. Fourth one.
dihaloalkane,
Yeah. Very good. Dihaloalkanes.
trihaloalkane,
Yeah. Very good. Trihalo.
dialkane, dihaloarene.
Yeah. Now you got my point. Haloarenes. Right. So just keep in mind there is the difference between cyclic structure and the aromatic system. Right. You can see. You have to check whether it's aromatic or not. Aromatic के लिए मैंने simple कहा है. That is your alternate double and single bond. You will see. Right. Just like a benzene ring. Okay. So that's the classification on the basis of number of halogen atoms. Yeah. Okay. Next one. Monohaloalkanes. That is very important. So basically, the monohaloalkanes are classified into two groups. First group, when the halogen group is attached to sp3 hybridized carbon. Now I told you, I just how to find out the sp3 hybridized or how to decide whether this carbon is sp3 hybridized, sp2 hybridized or sp hybridized. There is a very simple trick. When you see the carbon-carbon single bond, so this is your sp3 hybridized, right? अगर आप single bond देखते हो तो this is your sp3 hybridized. If you see the carbon-carbon double bond, right? So this is your sp2 hybridized, right? If you see the carbon-carbon triple bond, then it is your sp hybridized. Yeah, just keep in mind, right? If you see the carbon and between the carbon, there is only single bond, right? Saturated system. Single bond means saturated system, means alkane. Double and unsaturated are of two types, double bond and triple bond, right? Unsaturation are of two types, double bond and triple bond. So double bond is for alkene, right? This is for alkane, and the triple bond is for alkyne. And the single bond, we know that it's for alkene. Yeah, so that's the basic chemistry we have learned in the earlier classes, like 10th, 9th, में हमने पढ़ा था. Yeah. So
Yes.
just keep in mind this hybridization state. If you don't know how to find out the hybridization state, so just keep in mind. If there is a single bond between the carbon, so it's a sp3 hybridized carbon. Double bond, It's sp2 and triple bond, so it's sp. Yeah. Okay, now see, so basically monohaloalkanes are of two types. First one, if the halogen atom is directly attached to sp3 hybridized carbon. Okay, and the second is when the halogen group is attached to the sp2 hybridized carbon. Okay, and we are talking about the monohaloalkanes, means only one halogen group will be attached. Only one halogen group will be there because we are talking about the monohalogen haloalkanes classification. Yeah,
Yes.
and yeah, Aisha, please make sure you will write down in your notebook because after the class,
Okay.
I think you will forget that. Okay, so first try to understand the concept, and after that, just try to write on the notes. Yeah.
Okay.
So see, the monohaloalkane first type. Let's see the first type. So first type is when the halogen group is attached to sp3 hybridized carbon. Okay. So in this type, there are three types of halides. Three types: alkyl halide, allylic halide, or allylic haloalkanes. You can see, or the third one is your benzylic. Okay, so one by one we will discuss it. First one is your alkyl halide or alkyl halide. We call it as a halo. Yeah, it's a alkyl halide means haloalkane. Haloalkane basically, right? So just remember alkyl halide. Now see this fluorine. This is your structure. This is your structure, or you can write on this. You can see this is your CH3 here. This is your CH2. Again, this is your CH2, and here the fluorine group is attached. Now, see, this fluorine group is attached to this carbon, right? This is attached to this carbon. And you can see this carbon is attached to this carbon by a single bond, right? By a single
Yes.
bond. So, obviously, this is sp3 hybridized carbon, right? So, when the halogen group, because fluorine is a halogen, right? And fluorine is attached to this carbon is sp3 hybridized carbon, right? Because this is further attached to this carbon by a single bond. So this is known as sp3 hybridized carbon. So if the halogen group is directly attached to sp3 hybridized carbon, then it is known as alkyl halide, right? इसे हम क्या कहते हैं? Alkyl halide. Is it clear now?
Yes.
Now see, I just explain it to you how to find out the degree, like whether it's a primary halide, secondary halide, or tertiary one. So how to decide? Now see, this fluorine is attached to this carbon, right? This is your carbon here, right? यहाँ पे क्या है? This is your carbon. So you have to check this carbon. This carbon is further attached to how many? If this carbon is attached to only one group, then it is known as a primary alkyl halide. Now, if sometimes what happen if this carbon has a substituent over here, right? यहाँ पे क्या होता है? Substituent. Like if I attach to CH3 group over here, so you can see this fluorine is attached to this carbon, and you have to check this carbon is attached to how many groups. So this is one group, one bond, which is shared between these CH2, and here there is another, right? So if the carbon has is attached to two more groups, then it is known as secondary type of alkyl halide. I think there is a confusion. Yeah, is it clear? This is not clear, right?
No, can you repeat it?
Yeah, yeah, sure. See, I just told you, suppose uh, CH3, CH2, CH2, and yeah, if I write fluorine over here. Now see, and there's another structure. If I draw here, CH3, CH2, CH, and here CH3. Now you can see one, two, three, and yeah. Another structure is to, yeah, so you can see there are three structures, right? Now first, come to the first one. See here, I'm explaining it to you how to decide whether it's a primary, secondary, and tertiary halide. Okay, so primary, this is 1 degree means primary. This is second degree means secondary, and this is 3 degree means tertiary, right? Now for primary, you can see you have to check first the fluorine group, this halogen group. The halogen group is there, right? The fluorine is a halogen, right? So halogen group is attached to which carbon? This carbon, right?
Yes.
And this carbon is further attached to how many groups? How many
One.
groups? Only one group, right? So obviously, so you have to check this carbon is attached to how many groups. If it is attached to only one group, so this is known as primary. This is known as a primary 1 degree alkyl halide. Now see the second one. This fluorine is attached to this carbon, right? Now see this carbon is attached to how many groups? Just check
Two.
it. Obviously, this two one. This you can show. You can see the bond. This is your one group, and this is your two group. So this is your secondary. Yeah, is it clear, Aisha?
Yes.
Third one. This fluorine, this halogen group is attached to this carbon. Now check it. This carbon is attached to how many?
Three groups.
Three groups. So we call it as a 3 degree tertiary. Now is it clear how to find
Yes.
out the primary, secondary, and tertiary? Very good. You can write down. And after writing, just tell me this one, all the examples. Right, first, second, and third, fourth, which degree? You have to tell me the degree of these one.
Okay, I'm done.
Yeah, so tell me first one, what is the degree of this?
1 degree.
Yeah, it's primary. Second example,
2 degree.
yeah, you can see this carbon is attached to two groups. So this is second. You can say secondary, 1 degree means primary, secondary, and tertiary. For the third one,
Secondary.
yeah, it's secondary. And this one, for the fourth one,
Tertiary.
yeah, very good. Now you got that concept. Yeah, see the second type. Okay, see we are discussing the classification where the halogen group is attached directly to the sp3 hybridized carbon. Okay, so first was your alkyl halide, and the second is your allylic haloalkene or allylic halide. You can say allylic halide. So what is allylic halide? So basically in this halogen, see halogen is first attached to sp3 hybridized carbon, and this sp3 hybridized carbon is further attached to sp2 hybridized carbon. Means carbon-carbon double bond, right? I just told you carbon-carbon double bond is basically sp2 hybridized carbon. So what I said, allylic haloalkane or halide क्या होते हैं? So basically, allylic halide is basically when the halogen group is attached first to sp3 hybridized carbon, then further it is attached to the carbon which is sp2 hybridized. Right? So that is your allylic haloalkane. That is your allylic haloalkane. Let's see some examples. Suppose if I write CH2, CH, and CH2, and here the bromine. Now check it whether it's a allylic or not. So you have to check for the halogen group. See, here the halogen group is there, bromine, right? Yeah, so see here the halogen group is there, bromine, right? Bromine is attached to this carbon, and this carbon is sp3 hybridized, right? And sp3 hybridized is further connected to sp2 hybridized. This is your sp2 hybridized carbon. So this is your allylic type of halide. Right? इस टाइप के halide को क्या कहते हैं? This is your allylic type of halide. Is it clear now? Okay,
Yes.
let's see another example. You have to tell me whether it's a allylic or not, and you have to tell me the reason also. Okay, just check it out whether it's a allylic or not.
It is a lilac halide
Or can you please explain how it is allylic?
because a chlorine is attached to a carbon that is sp3 hybridized, and
Hmm?
then that carbon is
Yeah,
further attached to
further
sp.
attached to sp2. Yeah, this is the carbon-carbon double bond, which is sp2 hybridized carbon. Right, so this is your allylic type of haloalkane or halide, you can say. Third type is benzylic halide. Right. Now see what is benzylic halide. So in this case, the halogen is connected to the sp3 hybridized carbon first, and this sp3 hybridized carbon is attached to the aromatic system, right, to the benzene ring. This type of halide is known as benzylic halide. Again, I'm repeating, the halogen group is first attached to the sp3 hybridized carbon, then this sp3 hybridized carbon is further attached to the benzene ring, means the aromatic system, aromatic group. Then it is known as a benzylic halide. Clear? Let's see the
Yes.
examples of this. Suppose there is a benzene ring, and here the CH2 and bromine. Means the halogen group will not be directly attached to the benzene ring. First, the halogen group is attached to the sp3 hybridized carbon. Then that sp3 hybridized carbon is attached to the benzene ring. So this type of system is known as benzylic halide. Yeah,
Yeah.
is it clear?
Yes. Yes.
Now, now see. Okay, second classification. First we have done, right, when the halogen group is attached to sp3 hybridized carbon. So we have alkyl halide, allylic type of halide, and benzylic halide. Now the second type is when the halogen group is attached to the sp2 hybridized carbon. Yeah, Ayesha? sp2 hybridized carbon. So in this type, first one is your vinylic halide. First one is your vinylic halide. Now see in the vinylic type of halide, what happens? The halogen atom is directly connected to the carbon-carbon double bond. Means your sp2 hybridized carbon, right? So this type of hybridization or this type of halide is known as vinylic halide. Again, I'm repeating halogen group. You have to check out for the halogen group, and this is attached to the carbon-carbon double bond directly, right? So this halogen group is directly attached to sp2 hybridized carbon, means you carbon-carbon double bond you will see. So that type of halide is vinylic halide. Let's see the examples. See the first example. There is a bromine group, right? And this bromine group is directly attached to carbon-carbon double bond, means this is your sp2 hybridized carbon, right? So this type of halide is known as vinylic halide.
Lilac.
Yeah. See this example. Is this a vinylic? Yeah, yeah, it's a
Yes.
vinylic because you can see the chlorine group is attached to this carbon, and this carbon is basically a sp2 hybrid. Yeah. Second type in this is aryl halide. Yeah, means here haloarenes भी हम कहते हैं aryl halide को haloarenes, right? So in this, halogen group is directly attached to the benzene ring. It's very simple. What is aryl halide? Halogen group directly attached to the benzene ring, so it is known as a aryl halide. And you know it very well, this benzene ring, this carbon in the benzene ring is sp2 hybridized, right? sp2 hybridized. That's why this is a classification of this type. Is it clear? Example, if I write, suppose if I give the example of phenol, right? So phenol is example of aryl. So just a second, not a phenol. I have to use some halogen group, right? So if I
Yes.
write chlorine over here, right? So benzene, when the chlorine is directly attached to the benzene ring, then it is known as aryl halide. Yeah. And yeah, just keep in mind there is a difference between the benzylic halide and the arylic halide. Sometimes students do the mistake in these two. They got confused in these two because benzylic halide, they sometimes think benzylic name है, right? So what they think, they just attach directly to the benzene ring, right? They just halogen group को वो क्या करते हैं, just directly attach to the benzene. That's wrong. That's the case of aryl halide, right? There is a difference between benzylic halide and aryl halide. Benzylic halide में क्या होता है? This is a benzene ring.
Hal has
First,
to
it is, yeah, it's CH2, right? Then your halogen group. Halogen group is first attached to the sp3 hybridized carbon. Then this sp3 hybridized carbon is attached to the benzene ring, right? So that's a benzylic halide, right? What about the aryl halide? Here in this case, the halogen group is directly attached to the benzene ring, right? So that's the aryl halide. Okay, just remember the difference between these two. Yeah, is it clear, Aisha?
yes.
Very good. Okay, so you have written till here?
No, not yet.
Okay, yeah, just write down.
Can you scroll up
Yeah, yeah, sure.
more?
Yeah, written, Ayesha?
Yes.
Okay. Okay, let's do
Uh,
some questions.
1 second. Hello, yes.
Okay. What happened? Is there any problem?
No, it's just my cat was troubling me, so
Okay.
yes.
So, here's a question. Name the following halides and classify them as alkyl, allyl, benzyl, vinyl, or aryl halide. Okay. Try first question. Okay, this is the, you have to first write down the structure, right? So try to draw the structure. So this is your, yeah, so when the, this is your methyl group, this is in your bracket, right? So जो bracket में होता है, this shows the substituent, right? This shows the branching, right? So how we can just write down? So basically on, there's a CH group over here, and on the CH group there is a branching CH3. Okay, if I write CH3 over here and CH3 over here, right? So this is a CH3. Now again, this is a CH structure, and here the chlorine group is attached, and here again CH3. That's the structure of the first one. See, CH group. This is the CH group, right? And there are two substituent over here, CH3, right? CH3 twice means the this is attached to this carbon. So this, on this carbon, the CH3 group is there, and again the second CH3 group. And this is the CH group, right? And in the bracket, this is a substituent over here, right? Halogen group, and this is CH3 again, right? So try to name this first and classify them as a alkyl and which type of degree, primary one, secondary, or tertiary, right? First write down the name of this. You can see how to name this. First try to find the longest chain. Longest chain is your parent chain. Longest
Parents.
chain is your parent chain. So this is a parent chain. 1, 2, 3, 4. 4 carbon. What we named the 4 carbon chain? It's butane. Yeah, it's butane. You can see one single bond over here, right? So all are alkane. So it's butane. Butane. Now there are two substituent over here, right? When you start the numbering from here, so it will be 1, 2, 3, 4. Or when you start from the left, again it will be 1 and 2. And the 1 and 2, there is a substituent. So you can start from the here also 1, 2, 3, 4. Now this is chloro, C for chloro and M for methyl group. And alphabetically order, C comes first than M, right? So we just named it as a 2 chloro, 3 methyl butane. That's the name. Now you will tell me what is the, which type of halide is this? Alkyl, allyl, benzyl, which type?
Alkyl halide.
Yeah, very good. It's alkyl one. You can see you have to check for the halide group. Halogen group is attached to this carbon and this carbon is sp3 hybridized, right? And further you can check if there is a double bond, but there is a no double bond, right? So this is your alkyl one. This is your alkyl halide. And just tell me the degree of this.
2 degree.
Yeah?
2 degree.
Yeah,
Second.
it's 2 degree. It's secondary. Right, so it's your secondary. Now it's clear?
Yeah.
Yeah, do the second one.
Yes.
Quickly draw the second one as structure. That's very simple.
Yes. 1 second.
CH3, then CH2, right? Then CH. On CH, there is a substituent over here, CH3. Then CH, and here on CH also there is a substituent, which is C2H5, right? C2H5, ethyl group, and here the chlorine group is attached. Now see, if can we write C2H5 as CH2 and CH3? Can we just open this chain CH2 and CH3? It's very much similar, right? And it is not necessary, but first, yeah, tell me.
Can you repeat the C2H5 part?
See, this is the second question. So I'm just drawing the structure over here, CH3. After CH3, you can check the CH2 is there, then CH, right? And I just told you in the bracket, it just tells about the substituent, right? You see, just carbon say attached, right? So the carbon to which the CH3 is attached, right? So this is in bracket. So you can tell that you can just add the CH3 as a substituent over here, right? Now again, next move CH, and again this is in bracket, right? This is in bracket means it tells that this C2H5 is attached to this carbon, right? So that's why I have written here, I have attached this C2H5 as a on this carbon, right? And after that, there's a chlorine group, means this chlorine group is again attached to this carbon, right? So that's the structure. Now, when we have to write down the name, what we are supposed to do, first try to find the longest chain. Longest chain is the parent chain, right? Now, if you write down the name, so 1, 2, 3, 4. Now, these are also a carbon chain, right? So we can include this 2, 3, 4, 5, 6. It's a two carbon chain, right?
Yes.
Yeah, so it's two carbon chain, so you can take this. This is the longest chain, right?
Oh,
So see, you can write this C2H5 also as CH2 and CH3. Again, the same thing. See, two carbon and five hydrogen. It's C2H5 again, right? So can we write this as CH2 and CH3? Again, similar thing. Now, if we start the numbering from here on the right side, so we have to start the numbering from this carbon 1, 2, 3, 4, 5, 6. Now check where the substitutions are there. On the third position, chlorine is there. Third and fourth. Third and fourth. Now, if we have to start the numbering from from the left side, so it will 1, 2, 3, 4. Again, the same thing. इस साइड से भी आप start करोगे numbering, तो the substituent will get 3 and 4, and here also the substituent will get 3 and 4. Right, so you can start the numbering from whether you want to the numbering from the left side or right side, it is up to you. Yeah,
okay.
so I'm starting the numbering from the right side. So what will be the name? So on the third position, there is a chlorine group, and on the fourth position, there is a methyl group, right? And alphabetically order on when you write down, yeah, chlorine comes first. So you will write 3 chloro,
Blue, 4
right?
methyl,
4
same.
methyl, yeah, it's hexane. Yeah, now just tell me the which type of halide is this and what is the degree?
Alkyl halide 2 to 3.
Yeah, it's again alkyl halide and it's a secondary. Yeah, is it clear now? Okay. I will give you the rest of the question in your homework. Okay,
Okay.
the homework will be uploaded and you will get that. Yeah, so that's all for today. Any doubt, Aisha? Is
Uh,
everything is clear?
yes.
Yeah. Okay, now it's the time for the test. Please be ready with your copy and pen. I'm sharing a question paper with you. Mhm. Yeah, is it visible?
Yes.
Okay. See, this is your question. Basically, it consists of five questions, right? And marks are mentioned over here. Okay. First one, you have to write down the IUPAC nomenclature of the following. Now, first, try to write down in your notebook. After that, tell me the answer one.
Okay.
Then the first question, Ayesha.
Yes. One second. Yes, I'm done.
Okay,
The
tell me
first
the
one
answer.
is 2-bromobutane.
Second one,
3-hydroxypentane.
3-propyl.
I said propyl.
Now tell me what you said again.
I said 3-hydroxypentane.
3-hydroxypentane. Okay.
And
Third one.
1-hydroxy
Mhm.
2-bromo 4-ammonobenzene.
4-aminobenzene, right? Okay. Okay, to the second and third question. In the second question, you have to determine the oxidation state of the underlying species. Oxidation state.
I'm done.
Then the second one.
Yes.
Okay, then
Um,
that's it.
the answer for A is 6
Six.
and B is 7.
Do the third one. 25 kg of nitrogen N2 and 10 kg of H2 are mixed together to produce ammonia. So calculate the ammonia which is formed. And second part is calculate the amount of unreacted species. Unreacted species means your excess reagent, excess species.
Can you repeat?
Unreacted species means excess reagent, excess species. This is basically a question from the stoichiometric first unit, which we have done in the 11th standard. Some basic concepts. A stoichiometric question.
I don't know how to solve this one.
Are you sure you don't know? Just give it a try. First, try to write down the balanced chemical reaction, right? And along with the help of a balanced chemical reaction, you can find that. It's very easy.
Okay. Mm,
Okay, no problem. Try the next question. Four and five. Yeah. Basically, you have to calculate the mole fraction. Yes, done, Ayesha. Fourth one.
0.021.
Yeah, it's correct. 0.021. Good. Okay, to the last question. You have to tell me the hybridization state of each and every carbon. So in methane, if you draw the structure, it will be like this. Now tell me the hybridization state of this carbon.
sp3.
Yeah, so it's sp3. Now, if I draw this structure, CH3, this is Cu and this is CH3. Now just tell me the hybridization state of both this CH3 and this ketonic carbon. For this CH3,
sp3.
yeah. For this
sp3.
and for this,
sp2.
now for this, Aisha.
sp. Both of them sp.